and then the other one in blue. And I'm going to actually resnip this into a new screen so that we've got a little more room to work with, because this is just bad, but that you can't do anything about that. How this is. So, all right. So what you're supposed to do, and let's just focus on this part in red, is you're supposed to look at it as y1 is x plus 6. Okay. And you're supposed to be able to graph the equation of that line there. That line has a slope of 1. There's a 1 in front of the x, and the b value of 6. Okay. So it's if you just freehand sketch this, there's 6, rise of 1, run of 1, things like that. It's some sort of a line like this. Okay, something like that roughly. Is that okay?
Yeah.
Then you're supposed to say, okay, y2 is -8. This is a horizontal line. So your horizontal line here at -8 looks something like this. Okay, and we want to know where the line y1 is below, less than means below this other line. So it would be down here in this region. How does that look, feel compared to maybe what you've seen?
Good. It's just like it was a little bit confusing because I didn't have like the y.
Yes.
For it.
Right. So now we'll do the other one. y1 is x minus 3. So slope of 1, b value of -3. So somewhere there. These are parallel lines. So we got kind of same thing here, something that looks like that. And then y2 is -10. So I actually should maybe draw this one a little further. So that's a horizontal line down here, a little bit below the other one. And then you're doing a different thing this time. This time you want it to be above. Where is y1 or x minus 3 above -10? So that's all of this up here.
Where's my highlighter? Sorry, I'm trying to grab a highlighter. So
Sure. Yeah, it probably good to grab something to signify this.
I got it.
All right.
Okay.
All right. So B is similar in some ways. Let's go to B. We'll work on that. All right. So this one says to solve the compound inequality. In the previous one, it was an or. This is actually an and case. I don't remember how much we talked about that, but the one that's between is the and you can see that x plus 4 is between these two inequalities. Your focus should be on wherever the x is, like that.
Yeah. Would you subtract 4 from all sides?
Yes. So -2 less than or equal to x less than or equal to 3. Go ahead and try graphing that on the number line here in one dimension. Do you have it?
So yeah, it's a closed circle from -2 and 3, and it goes between, and it's a closed circle for both.
Yes, yes, and make that really clear on your graph. Like, don't leave any question unless you're really unsure. But you've got it down. I would do interval notation, I guess, from that one. Because it's filled in, you're going to use brackets this time. So it should be bracket -2 to 3, like that.
Okay, yeah, that's what I wrote down.
Now the set builder really comes from the solving the inequality. So you have this preamble x such that x is an element of the real numbers, comma, and then you put the inequality right there. And then these things called curly braces, they're on your keyboard as well if you're not sure what I'm drawing. And I think they'll get, you can get away with sort of scribbly lines.
Yeah, that's what I do. It's almost like a huge like 3, but with a point going outwards.
There is a shape to it. Are you an artistic person?
Yes.
Okay, so there is a nice curvature to them. This is the correct way to draw them. Hopefully you can see this. And then if you draw it slowly, it's got this nice symmetry there.
Yeah, that's what I do. I could like show you.
No, I'm just, in case you were wondering how to actually draw it. Sometimes they don't mention.
Yeah.
Oh,
That's how I do mine.
I can't read backwards anyway. So thank you. Cool. All right. Now to the graphing, right? The graphing, so bad. Let me reset this with another snip here. You've not done anything wrong. This is just not the right way to present this information. So there are 3 y's this time. And I'll do y1 as the one in the middle. y1 equals x plus 4. What is the slope and the b value of that?
So the slope is 1 and the b value is +4.
Good. So if you want to, I don't know how accurate you need to be. If you need to put the little tick marks in. It depends on what the instructor wants. How accurate do you need to be? Something like that. Okay. All right, so there's your line. Then you want to graph. I'm going to do this in different color here, just for clarity. Y2 is 2. So 2 is kind of this line here. It's good to label these. Let me go back and label the other one. And then the last one there is 3. Sorry, Y3 is 7. And it's okay. I mean, if you want to bring colored pencils to class, like I think it's very helpful. You'll see this a lot in college. Students are very diligent about their notes, figuring out ways to make connections with colors and things like that. So this time we want we want it to be between. So between is just like on the number line there. Below the 7, but above that. And I did make one error here earlier. It's not it's in this one on the right here is what did I write? Okay. So this one, it's not equal to, didn't even catch that. And this makes this a bubble. There are 3. And then that does change this to a parenthesis. I guess in my head, I wanted it to be the same in both places. So I apologize for that. I know that's very confusing and unclear. Hopefully it's better now.
Finish that.
Awesome. Okay, so we can go to absolute value inequalities next. Does that work? Number 3. All right. I don't know if we'll have enough time to go through everything. That's why I'm asking if you want us to move around at all. But okay, so total switch. You're now doing absolute value functions. That's what the g of x is. It's a function.
Yeah.
The vertical bars mean absolute value. State the key features and list the transformation includes all features, vertex, slopes, axis symmetry, x and y intercepts, and so on. They're trying to help you put that together here. There are 1, 2, three transformations from the original function up here. Can you tell me any of them in any order? I'll just sort of listen, see what you think, what you see.
The 2, would it be a stretch of 2?
Vertical stretch of 2.
I forgot what H and K do.
So and I really like that you said H and K. That's good stuff. H and K refer to the vertex. So let's just say the vertex, and I'll plot it for you so you can maybe get a better sense of it. There's your vertex. Relative to the origin, how much right or left did you move? How much up or down did you move to get there?
Would you move to like the right one?
Yes. Right
And like
one.
down 4?
Yes. So I want you to stare real hard at the x minus 1 inside parentheses and try to somehow come up with some own reasoning for yourself so that you can do this on the test tomorrow. Like why it's right 1 for you. Like, how are you going to remember that negative means right 1? So whatever you come up with would be good. But it's always opposite sign inside the parentheses there, inside the absolute value.
Mm-hmm.
And then the down 4 is that's just standard. Yeah, it's down 4. Okay, we kind of already alluded to this. The vertex is H, comma K. Your H is 1 and negative 4. Notice that comes from the right 1 and down 4.
Mm-hmm.
It's very easy to kind of miss this. So maybe after this problem, I'll give you a few to check your understanding of the vertex on. All right. The slope actually comes from the vertical stretch.
2/1.
Yeah. And the reason that's so important is like if you go to the vertex and you know whether it opens up or down, you can then use the slope to go from that vertex point up to right 1, up to right 1, and so on. Okay. And by symmetry, you get the other side. I think that looks right. It's just because the picture being at an angle, I think that's correct. It's just doesn't look great, but hopefully yours on your paper looks good.
Yeah.
All right. G of 0. This means to put 0 in for x.
X.
Okay. Up here at the top. Would you attempt to calculate that for us, please?
Mm-hmm. I don't think there's a point for that.
This is what I'm asking you to do. Is that what you have written down? Something like this?
No, I thought you were asking for like the point.
No, so 0 in for x means to go back to the original equation, replace x with that number, 0 in this case, order of operations, right? You subtract 1.
Mm-hmm. Would you add 4 to both sides?
There's no sides here. This is just a simplification. Like you first subtract 1 from 0, which is negative 1.
1.
Take the absolute value of that, which is 1, multiply by the 2, and then subtract 4.
And then for the g of x is for the y.
Well, let's just like take a breath here and be like, okay, what does that even mean? Okay, you got 0, negative 2, right? So if you look, there's actually that point on the graph there. We just happen to get it from the slope. But what axis did it just cross?
The y.
Yes. So that represents what's called the y-intercept. It's kind of like when you're reading a book right? You get to like that really compelling part of the story. Like, I know you like we just want to read forward, but sometimes you just take a moment and you pause and you're like, okay, like what just happened here? At least that's what I
Yeah.
do when I read. All right. And and some of the questions you were asking me about when we were simplifying, they do apply to this next part. This next part means to set the equation equal to 0. Okay. Set 2 absolute value x minus 1 minus 4 equal to 0. Question?
-1.
Okay, there's actually two answers. So let's go through this together. You're going to add 4 to both sides because there's an equal sign. 2 absolute value x minus.
It's -1 and 3.
Yes. Now, did you get that from solving this or just from the graph?
The graph.
Okay. So while that's true, it's important in math class, right? To you've seen this like your whole life. Show your work, right? Now, if you were in my classroom and you just said what you said, I'd say, yeah, that's good enough, but your teacher likely wants you to work through this way. So go ahead and get caught up to this point, and then we can talk about what to do, because this may be something we haven't seen in a while.
Okay. I got it.
All right. So absolute value ends up being kind of this case 1, case 2. I know it's awful. All right, and then to solve, you add 1 to both sides. So get exactly what you said, x equals 3, x equals -1. The reason you should keep this in mind is you may get a problem where it does not have an x-intercept, or it's not nice, like it's not that perfect, hits it in the right spot.
Mm-hmm.
That's why it would be something to consider. Okay, now I'm sorry for all the scrolling. I'm trying to get this just centered a little better. There it is. The way your tests are written, you really want to go through and make sure you have like checked all the boxes. Do you have a vertex? Yes. You've got the vertex. Did you get the slopes? Yes. Did you get the axis of symmetry? No, we did not do that, right?
Oh.
And the way your tests are written, they put all this stuff in the top, and you got to kind of like make sure you did all that. The axis of symmetry goes through the vertex. So it's x equals h. In your problem, that's x equals 1. And then last thing here, it says x and y intercepts. We've got those. The thing though that I didn't do, I'm real bad about this, is I don't actually label the points. So I'll label some. That's the vertex. The y-intercept is 0, -2. And the x-intercepts, you said them earlier, 3, 0, and -1, 0.
B seems confusing.
Before we get to that, anything to say about A? Any follow-up?
Mm-mm.
Okay. All right. Okay, let me grab it here. There are a couple of ways to do B. One is to go right to the graph and do it. The other is to do it by hand and then go to the graph and just kind of like see if it's consistent with what you think. Do you feel like you'd rather go to the graph or work this out by hand? What would be best for you?
I have no clue.
Okay. Do you agree though that we've already graphed this one on the graph there?
Yeah.
So think of that as your y1. Okay. And then y2, running out of colors here. Let me see, what color have I not used in this graph? Green. Okay. We'll make the 6 y2. Okay. So we're going to go back to the graph and you're going to 6 and you're drawing that horizontal line there. And now what I have to do, because I didn't really fully sketch this out, is I got to keep graphing the points here like that. And if you've done a really nice job graphing, which I'm sure you have, because you're a little more artistic than me, can tell, you want to label those ordered pairs, and they should, hit in the nice spot there.
-4 and
6.
6.
Yep.
And then the other side.
The right side there.
6.
6, 6.
And then does he want us to just like shade above?
Let's get to that. So let's go back and look at it because it's an oddly written inequality here. I prefer the equation to be on the left side. So where is y1 less than or equal to y2? Where is the absolute value below the horizontal line? That's how you want to read that notation. And just make sure you're comfortable with how I flip that. The arrow is still pointing out to y1. So in terms of where you shade, great, got to add yet another color to this.
Just below the line.
It's all this V area like that.
Okay.
All right, there's more to do on that one, but we got the graphing down. So if I scroll down, I think I might have to snip that next part in. Yeah, they want you to do, set builder and interval notation. So what you're trying to figure out is where is this true? And these both refer to the X values. So that's why the ordered pairs were so important. Do you see that it is between the X value of -4 and the X value of 6?
Yeah.
So that's what they're looking for. It's almost better to put it on a number line. So like -4 to 6 and we want between them.
Between.
So could you try to do the interval notation for us? It's a lot like one of the earlier ones we did. There's no difference there.
So would it be the brackets from -4 to 6 with a bracket or on both?
So this time it is a bracket around both -4, comma 6.
How would you do the set builder for this one?
Yeah, so it's like this is the first time we haven't had an inequality to work from, but maybe you can see how it's built. Do you see that -4 surrounds the X that's between -4 and 6? Like this filled in dot becomes that, this filled in dot becomes that.
So it's just the x bar, XER, comma, and then that?
Yes.
Okay.
All right, so now it says show 3 possible solutions to the inequality. Let me snip that in here. So you're looking for numbers between -4 and 6. Okay, so do you just pick one or pick 3? Do you want me to pick or do you want to pick?
Could you pick?
Okay, I'll pick one. You got to pick one then after. I'll pick 0. Is 0 between -4 and 6?
Yes.
Okay, so that's all the criteria I'm using.
That's what I do. He says he'll still give me the points because he's like, for showing it, he does the equation, but he says we can also just point an arrow to the graph.
Okay, well, we're going to go through the equation too, because I noticed earlier it was a little bit of a struggle to do that. Give me a negative value and a positive value for us to work with.
-3 and 5.
Okay, so what we're going to do, and I'll do the 0 one here. So we're going to do it in this part of the inequality. 2 absolute values, 0, -1, -4. So you're just simplifying. You're just evaluating in order. 0 -1 is -1. Absolute value of -1 is 1. This becomes 2 times 1. 2 -4 is -2. And then at the end, or you can bring it down in the beginning, but like you're basically asking, is this true? Is 6 greater than or equal to -2? Yes.
Yeah.
Okay. All right. So I want you to pick one or the other. I'd recommend doing the 5. Probably be slightly easier, but I want you to work that out for us, please.
Mm, so would you multiply the 2 by the 4?
Yes.
And then it would be 8 minus 4, correct?
Yes.
Mm,
So is 6 greater than or equal to 4?
yeah.
All right, so that we're good. You did such a good job on that one. Why don't you try why don't you try -3 here? Remember the absolute value of a negative number always returns a positive number, or the absolute value, say like -6, becomes +6. And if you have questions, please ask. Be happy to help.
Okay. Would it be 6 is greater than or equal to 2?
So 2 absolute value -3 -1 -4. -3 -1 is -4. Okay. And let's talk about why. Let's say you owe someone $3 and then you owe them another dollar. You now owe them $4. Sometimes money is a great way to look at adding and subtracting. And the absolute value of -4 would be 4. 2 times 4 -4, 8 -4 is 4. Now, if like you said, you can just point to the graph. I mean, it's hard for me to say not to do that because that's kind of what the instructor wants, but this is the more appropriate way to do it.
Mm-hmm.
Yeah, I can't really speak to the benefits of doing this way. It's more work. It's prone to making errors, but it is the, better path here.
Yeah. Earlier today, I was so confused because when we were doing this and we asked what interval notation was, he was like, I want the set builder notation and I want those little bits and chunky pieces. I was like, what is
Wow.
that? And he was like, the interval notation. And I was like, what? And then once he did it, he showed us what it was. And I was like, oh. Because he
So
called it
set
the
builder notation, they called it the what?
he called it the bits and chunky pieces.
Okay. I don't know. I think of food when I think of that, but I don't know. I just get through the school year and hope you get a better teacher next year so that you can,
Yeah.
not repeat the same sort of struggles on this front. We've got just enough time here probably to get 4 done, so that will be good. You'll at least may have seen one of each type of problem that you'll have on the test here. This one has one. Let me back up here. One. Really struggling here. 1, 2, 3, 4. 4 transformations here. Can you tell me any of the transformations that you see?
The slope is -1/2.
So notice there's no slope word here. The slope only applies to absolute value.
Oh wait, this is that's a quadratic.
Yes, good. That's good. Glad you identified that. I'm just going to step away for 30 seconds. If you don't mind, just take a moment to look at that. I'll be right back and say hello when I'm back. All right. Any of these transformations?
Would it be like down 1 and right 8?
All right. Let's go back and look at the previous one. This previous one was really correct. Let's look at why. Well, it was way up here. Okay. So why was it right 1? What was it about it that made it right 1 here?
Because it was minus.
Okay. So by like reasonable logic, if it were +1, it would be left 1. Would that make sense? Okay, now let's go look at yours down here. What do you have to say here? Is it right or left 1?
Left.
Okay, but this one was right 1.
So it'd be right.
Yeah. Now, do you remember me like, I don't know, maybe 5-10 minutes, you mean like, you got to figure out a way to remember this. Like there's somehow you have to convince yourself like, okay, if it's subtraction, it's right. If it's addition, it's left. Like somehow you have to get that clear. All right. So yeah, you've got it now. It is right 1. The number on the outside, it's what it looks like intuitively.
So would it be like up 8 or
Up
down
8,
8?
up 8. So again, like keep going back and forth here, but this one -4 down 4. Okay. Because it's minus. Like when it's on the outside of the function, it's more intuitive. It's more what you think it should be. Whereas when it's inside, it's always kind of the opposite. So yeah. Now this 1/2 here is on the outside is a vertical shrink. And then what does the negative do? Do you remember that?
Flips it upside down.
So that what you said is correct. The language they're looking for is reflection over the x-axis. because it could actually reflect over the y-axis in a different scenario. Let me know when you get that down.
So 8 would be the 8 would be like the vertex, and
8 is part of the vertex. It's the second value. The first value comes from right 1.
so it would be like 1 comma 8.
Yes, very good. We can put that right there.
How do I tell what, like, how much to move down to make the other points?
The way I read this is you just need to graph the, not to try to not answer your question, but like they just want the y-intercept and the x-intercepts.
Mm-hmm.
The way to do this is more difficult than you would probably want to know at this point. It's not like absolute value where you just use it as the slope.
Mm-hmm.
There's the quadratics have a changing slope between the points. So you'd have to know the slope from the parent function between 2 points, and then you would change it from there.
But the parent function is completely different.
So say that again.
The parent function is completely different.
Right. So here's what I'm saying, that if you remember how most quadratics go down 1
Mm-hmm.
like that. So the fact that it's 1/2 will impact that. It will only go down 1/2.
Oh.
And I didn't think, and then the next point is you go right 1, but then down 2. So like your next point would be there, but then that's scaled because that's got a slope of 2, it's scaled 1, but it's relative to that other point. So anyway, you don't want to do that. Is, long ways trying to get you to agree with that. Let's go to j of 0. J of 0 means to put 0 in for x. Could you attempt to do that for us, please?
Would it be negative 1/2 times 1 plus 8?
Yes. And unfortunately, that isn't a nice number, right? It's like, what is that? It's you can go to the calculator if you need to. I don't remember if you said you're allowed to do that. 8 is really 8 over 1 or 16 over 2. Or 7.5, if you will.
Yeah, he gets mad when we put
We'll
decimals,
get
which
so
I'm more comfortable with, but he hates when we use decimals.
so write the decimal so you know where to put the point, but then write it the way the instructor wants. This is all about giving the instructor what they want.
So 7 point.
All right. And then last one here, j of x equals 0. You're setting the equation equal to 0.
Zero.
This one's a little bit more involved, but you're setting it equal to 0. Let's step through this together. Let's subtract 8 from both sides. Negative 1/2 x minus 1 squared equals negative 8. How do you clear a fraction when it's multiplying? Do you remember that?
I forgot. Would you multiply by the denominator out?
If you can do that,
Or
that's a
flip
good,
it?
but the reciprocal is the full way to do it. Like what you said gets you closer. This is the full part. So that's x minus 1 squared equals 16. How do you undo the square?
I don't know.
Square root function. plus or minus. So then the left here, it's x minus 1 equals plus or minus 4. So your x squared is undone by a square root. The square root of x is undone by a square. And so this becomes two equations. It becomes x minus 1 equals 4, x minus 1 equals minus 4. So you solve these by adding 1 to both sides. And you get x equals 5, x equals minus 3. All right, so I'll go ahead and label those points here, and we'll look at the graph, or we'll have to look at the graph in more detail another time, but 5 and minus 3, 5 and minus 3. And that's kind of enough to create this shape to it. All right. So we do have to stop here for tonight.